Hello and welcome to another episode of Differential Calculus with Sir R Squared. In this video, we're going to discuss about derivatives of trigonometric functions. We are still referencing Calculus with Analytic Geometry by Thurman Peterson. Learning Objectives and Outcomes. Ang pangunahing layunin ng bidyong ito ay maturuan ang mga mag-aaral kung paano mag-solve ng derivatives ng trigonometric function. At ang kahihinatnan ay matututunan ng mga mag-aaral ang pagsosolve ng derivatives of trigonometric function at magamit ito sa aktwal na aplikasyon na may kaugnayan sa siyensya, engineering at teknolohiya. Disclaimer: ang bidyong ito ay ginawa ng may akda upang magamit sa pagtuturo ng matematika at maging sandigan ng mag-aaral sa kanilang pag-aaral ng calculus. Ang bidyong ito ay maaaring mai-download ng walang bayad or for free sa www.youtube.com. Ano man pong maling paggamit sa bidyong ito maliban sa nasa saad sa taas ay hindi po responsibilidad ng may akda. This video is not regulated by the institution. Any flaws in this video is at author's imperfection. This table summarizes the derivatives of the 6 trigonometric functions as well as their chain rule counterparts. That is the sine, cosine, etc. of the function. Dito po sa first column, makikita natin yung original rule at dito naman po sa second column, makikita natin yung general rule o yung tinatawag natin na chain rule. So, the derivative of sine x with respect to x is equal to cosine x. The derivative of cosine x with respect to x is equal to negative sine x. The derivative of tangent x with respect to x is equal to secant squared x. The derivative of cotangent x with respect to x is equal to negative cosecant squared x. The derivative of secant x with respect to x is equal to secant x tangent x. And lastly, the derivative of cosecant x with respect to x is equal to negative cosecant x cotangent x. Sa generalized rule naman po, wala naman pong pinagkaiba. Ganun pa rin po yung function. The derivative of the function is just the same as the original rule. Kaya lang dito po ay ginawa nating variable yung hindi po x, ano? Ang x po kasi, ang derivative niya is 1. So, dito po, ginawa niyang generalize, ginawa niyang any variable, u. So, the derivative of sine u with respect to x is equal to cosine u, and then you have to multiply it by du dx. Yun po yung naging parte ng chain rule. Mas magagamit po natin itong second na to kaysa dito kasi hindi naman po lahat ng trigonometric function ay sa x lamang po naka-express. Minsan po sa t. Minsan naman po hindi lamang x, 3x pa, no? May derivative pa. So, ang ibig sabihin lamang po dito, sa functions, pareho siya ng derivative, kaya lang you have to multiply it by the derivative of u with respect to x. Okay, the second formula is derivative of cosine u with respect to x is equal to the negative sine u times du dx, or the derivative of u with respect to x. No? The derivative of tangent u with respect to x is equal to secant squared u times derivative of u with respect to x. Kukunin mo pa yung derivative nitong yung ito. No? Yun lang po ang pinagkaiba rito. Kasi dito, pag kinuha mo yung derivative nitong x, that will be 1. So, this is a more generalized rule. But they're just basically the same. The derivative of cotangent u with respect to x is equal to negative cosecant squared u du dx. the derivative of secant u with respect to x is equal to secant u tangent u du dx. The derivative of cosecant u with respect to x is equal to negative cosecant u cotangent u du dx. So, ito lamang po ang bumubuo ng ating trigonometric functions, derivative of trigonometric functions. Iba pa rin naman po yung sa inverse, ano? Ngayon, I would like to remind each and everyone, lalo na dun sa mga students ko, meron po akong in-upload sa ating module na mga trigonometric identities. I prepare not to include that to this video kasi hahaba lang, and dapat sa trigonometry pa lang ay alam na natin yon, ano? In-upload ko po yun sa ating module at paki-review na lamang po lahat yung mga trigonometric identities na nandun dahil magagamit po natin yon sigurado sa pagkuha ng derivatives nitong trigonometric functions. We go now to examples. Number 1, find the derivative of secant x cubed. Now, let us recall the formula for the derivative of secant x with respect to x. Sa generalized form, derivative of secant u with respect to x is equal to secant u tangent u du dx. Sige nga, isulat po natin yan para sa una, may guide tayo. Ang derivative daw ng secant u with respect to x is equal to secant u tangent u and then times du over dx. Sabihin natin dito, that will be equal to secant x cubed tangent x cubed times the derivative of x cubed with respect to x. So, yan po yung ating first line, ano? Then, the second line will be secant x cubed times tangent x cubed. Then we are now going to take the derivative of this one. This will be 3x squared times 3x squared. Therefore, the derivative of secant x cubed will be 3x squared times secant x cubed times tangent x cubed. So this will be the derivative. Example number 2. Find the derivative of y is equal to 3 sine cube of 2x to the fourth plus 1. So basically, chain rule pa rin po yan, ano? Wala pong pinag-iba yan dun sa ating algebraic. Let us recall yung mga ginagawa natin sa algebraic function. Nagmumukha lang pong mahirap ito kasi trigonometric function, but basically pare-parehas lang po yan, ano? Anong sabi natin sa chain rule? Ang chain rule po, sabi natin, derivative of the outside, then copy the inside, and then we have to multiply that by the derivative of the inside. Ayan. Yan po yung ating chain rule. Natatandaan ko, nilagyan pa natin ng clouds na ganyan. Okay? So that mas madali nating maintindihan kaysa magle-let you tayo, no? Okay, tingnan po natin, i-apply po natin dito sa equation na to. First off, we have to analyze sine cube 2x to the fourth plus 1. We can rewrite this equation. Let us try to rewrite this one for more clarity. Y is equal to 3, tapos meron tayong sine of 2x to the fourth plus 1, and then we have to cube that. Tama. So we can rewrite it like that. Now, we can easily apply chain rule. Kung sanay ka naman kagad sa tingin pa lang dito, wag mo nang i-rewrite, ano? Kagad-agad makikita mong 9 sign na yon. Okay, and then i-square mo yun sa kabila. Pero dito, mas madali mong makikita kapag nire-write mo. Let us get the y prime and apply the chain rule. Y prime is equal to derivative of the outside. What is the outside function? This one is the outside function. This one. 3 times 3, tas magiging 3 minus 1 to, no? Sige, let us try to do that. So that will be 9 times the quantity sine, copy the inside, 2x to the fourth plus 1. Ayan po yung paliwanag, ano? Tapos, ito na po yung 2 kasi derivative of the outside nga po tayo. And then, nakakopya na rin po natin yung inside. We are done with the first cloud. And then, we have to multiply that by the derivative of the inside. What is the derivative of the inside? Ano po yung inside function na pinag-uusapan natin? Ito naman, i-highlight ko ng green. What is the derivative of sine? 2x to the fourth plus 1. Recall that the derivative of sine is cosine. U, du dx. O, yan po. The derivative of sine u with respect to x is equal to cosine u times du over dx. Sinulat ko lang pong ganyan. Ano? Okay, i-apply po natin dito. Times the derivative of the inside, that will be cosine u. What is u? This will be 2x to the fourth plus 1 times du dx. What is du dx? This one is du. Okay, burahin po natin at gugulo. Yan. Du dx, that will be 8x cubed. Ayan. Basically, tapos na po tayo sa ating derivative. Okay? Ganyan lang po talaga kadali kapag ina-apply mo lang yung chain rule, no? So, what will happen is we just have to rearrange the terms. 8x cubed times 9, y prime will be equal to 72x cubed. Tapos, sine squared. Sine squared na lang to. Kasi binalik natin sa form na yon kasi nagpa-finalize na tayo, no? 2x to the fourth plus 1 and then times cosine 2x to the fourth plus 1. Ayan. Yan po ang ating final answer. Sa book po, at kung meron kayong mga ibang application na ginagamit, maaaring magiging iba ang presentasyon nila ng solution. Pero just the same, dito pa rin po babagsak yung final answer niyan. So kung saan po kayo madalian, ano, kung dito sa pinipresent ko or sa ipinipresent ng mga book, just the same, sa chain rule lang po naman pareho namin kinuha yan. Okay. We have example number 3, differentiate y is equal to cosine cube tangent 3x. Basically, kung ano yung operation na ginagawa natin sa algebraic function, ganun din ang gagawin natin dito. Kaya lang nagmumukhang mahirap po ito kasi trigonometric function nga, no? Meron tayong cosine cube, tas pumatong pa yung tangent 3x sa loob, no? The same banana, wala po tayong dapat ikabahala. Pareho pa rin po yung mga process. Kailangan lang po natin ipalo po itong chain rule. Hindi ko na nga po binura dahil para may guide tayo. Derivative of the outside, then copy the inside, multiplied by the derivative of the inside. But first off, we try to rewrite the equation. Y is equal to cosine and then tangent of 3x, and then we have to cube that. So kitang-kita natin na yung outside function niya ay naka-cube. So we try to get the derivative and we say y prime is equal to itong 3 ito bababa, 3 times cosine of tangent 3x. Tapos mababawasan squared. And then that will be the outside function. Ang inside function po natin ay ito. Itong buong ito. So that will be the derivative of cosine. So the derivative of cosine u with respect to x is equal to negative sine u du over dx. Okay. Ang u po natin, i-define natin yung u. U is equal to tangent of 3x. Ito po yun. Cosine u kasi, ayun yun. So, ano yung du dx natin? Du over dx is equal to derivative ng tangent is secant squared u. That is 3x times du dx. Ito na yung u niya ngayon, times 3 pa yan. So, therefore, let us try to do the derivative of the inside. We have cosine, therefore we have to multiply it by negative sine of tangent 3x. So, that will be the derivative of cosine multiplied by du dx, which is 3 secant squared 3x. Ayan. Yan na po yung ating nakuha sa chain rule. All we have to do is to rearrange and finalize our answer. So, we have to say y prime is equal to ito 3, ito negative, ito 3 din. That will be negative 9. Ito naman naka-square yung cosine. Pwede natin sabihin cosine squared of tangent 3x. Ganyan. Okay. Tapos, wala na yung negative doon. Sine of tangent 3x, and then meron tayong naiwang secant squared 3x. So basically, ito na po yung ating nakukuhang final answer. All we need to do is to double check kung meron tayong naiwan, ano? This will be 3 negative and 3, that will be negative 9 cosine squared tangent 3x. And then, wala na yung negative dito, napunta na sa labas. Sine of tangent 3x, secant squared 3x. Ito po ang ating final answer. Now, sa mga books or sa internet, kapag nag-search kayo, baka merong ibang klaseng approach other than this. Yun po yung mga nagle-let you sila na kagaya nito, no? Pwede rin naman po yun, kaya lang ito po sarili kong preference kasi nga mas nadadalian po ako dito sa ganitong klaseng chain rule. But nevertheless, kayo rin po ang magsosolve, edi kayo rin po ang masusunod kung saan po mas madali para sa inyo at convenient. Sigurado namang masusundan yung, kung exam man, sigurado masusundan yung solution ninyo ng inyong respective professors, no? So, para sa akin, I am convenient using this derivative of the outside and copy the inside multiplied by the derivative of the inside. Yung iba naman, kagaya nga na isinample ko dito, nagle-let you sila, no? Let u is equal to tangent 3x. Ginawa na natin yan dito. So, ang du dx natin, ito yung, tapos ibabalik mo sa substitution. Okay, I hope with this, alam nyo na kung paano isinosolve yung ating mga trigonometric function using chain rule. For ease of uploading, we have to terminate at this point and be back with another video showing more examples in solving derivatives of trigonometric functions. At sa wakas ng lahat ng bagay, tayo po'y magpasalamat sa Panginoon Diyos sa pagbibigay sa atin ng lakas at buhay upang mapag-aralan at matutunan ang mga bagay nito. Ang lahat ng parangal at papuri ay sa iyo, Diyos amang makapangyarihan sa lahat, na naghahari noon, ngayon at magpakailanman, magpasawalang hanggan. Amen. To God be the glory.